Hello students, in today's video we are going to cover question number 18, and in writing part this is your question number 3. Okay, so what exactly the question is? Determine the instantaneous power. Okay, power is equals to work done by time or F dot V by taking the dot product, okay, the second one of the force factor and the velocity vector. Fine. Okay, relate the total energy to the mechanical energy. Okay, total energy to the mechanical energy. Okay, this is major thing, huh? So in that case you have the other energies also. Generally what we know kinetic energy initial plus potential energy initial equal kinetic energy final plus potential energy final. But now what you need to understand, total mechanical energy and the total energy. So in that case the formula is E total is equals to mechanical plus others. Mechanical means kinetic plus potential and the other energies also. Fine, like a spring energy. So you need to focus on that part. Last part is work energy theorem and for the known conservative forces. So in that case total work done should be equals to kinetic plus potential. Fine. Okay, we are going to solve the numerical number 1 on the basis of that. And in this part I'm going to cover 4 numericals: 1, 2, 3 and 4. Okay, let's see. Question number 1. A bicyclist goes down, theta is given, theta is 4.2 degree, slope at a steady speed, okay, velocity is given 5.1 meter per second, okay, assuming a total mass is 82.2 kg, okay, total means bicycle plus the rider. What is the power output? Okay, we are looking for power. Fine. Must be cyclist expand to pedal up the same slope. This is something very important. At the same speed, guys, same slope with same speed. This is very important. That will change your question. If the speed is same, v is constant. Speed same means constant. It means acceleration is 0. It means force should be 0. Clear? Means no additional force you need to apply. Okay, what you need to understand in this is something very important. Huh? Let's say this is your cyclist here. First part you should know, this is the mg. Clear? Okay, now if you solve it, if you break it, this will become your, okay, here is your angle theta, mg cos theta. Clear? Okay, now here we have mg sine of theta, mg sine theta. Fine. And we have the normal like this, exactly up. This is your normal. Fine, guys. Okay, now what you need to understand, the mg is going down, yes or no? Okay, force applied is going up. So we understand from this diagram, F is equals to mg sine of theta. They balance each other, balance each other, yes or no? Okay, but still you want to go up, so you need additional force because they balance each other. The net result is 0. If you want to go up, you need additional force F. So how much force you have now? Just think and tell me. Let's say one force is already, one force additional F. So how much force you have? You have total 2 force. Do you understand? If you want to go up with the same speed, you want 2 force. So guys, now solve it. So what is the value? Now we are looking for power. Power is equals to force, net force, F net multiply V. So what is the F net? 2 times of force multiply V. What is the 2? 2, what is the force? mg sine of theta multiply V. Okay, just place the values. 2, what is the value of m? Just tell me, what is the value of m? 82.2. okay, multiply g is 9.81, multiply sine, angle is given, angle 4.2 degree, 4.2 degree, multiply, what is the velocity? Velocity is given 5.1. just place all these values and you will get the value 602.391 watt, because we are looking for power. Clear, guys? You understand why I make it 2 times? Because to balance it, so that the same force is applied and it's keep on moving up. Clear? Okay, next question. Wow, this is something very good one, huh? Okay, a boy on sled start from the rest and slides down the snow-curved hill. Together the boy and sled have a mass of 23 kg. Okay, both mass, we get the mass of 23 kg. The hill slopes make an angle of 35 degree. Okay, with the horizontal. The surface of the hill is 25 meter long. The surface of the hill means distance d1. This distance d1. When the boy and the sled reaches the bottom, okay, of the hill, they continue sliding on a horizontal snow-covered field. The coefficient of friction, kinetic friction, is this. Mu is given. How far the body and sled move on the horizontal field before stopping. Before stopping means V final should be equals to 0. Okay, what we get? When it starts, V initial is 0. Okay, mass is given 23 kg. Theta is 35 degrees Celsius. Okay, distance d1 is how much? 25 meter. Okay, what you need to do? You need to solve. Okay, one more thing. mu1 is 0.1 and velocity final is 0. Okay, you need to divide this question into 2 parts so that you can solve this. Okay, and what you need to understand, the total energy, the basic thing what you need to understand, total energy at the top here, at the top, clear, should be equals to total energy of the motion plus it's moving down, total energy down. Okay, remove this one. So whatever is going down, yes or no? Sure. Okay, now we need to solve this. So first step number 1, what is the total energy? Total energy, let's say this is point A, this is your point A. So what is the total energy? Can I say negative mgh? Why negative? Because moving or motion is down, we are going down. Fine, you understand? Okay, so what is the height? Height is this one. Okay, I'll change the color. This is your height. Okay, solve this. So we have something is going down. This is your height, like this. This is your distance d1. Here is angle theta. This is your height, which will equals d1 sine theta, and the base should be equals to d1 cos of theta. So can I solve it? Total energy is equals to negative mg. What is the value of h? d1 sine of theta. This is your equation number 1. Clear? Fine. Okay, now solve your question and divide it into 2 parts, part 1 and part 2. Okay, part 1, when you are going down, we need to solve this, and second part is going straight. Okay, let's say when the body starts moving from here, so there is a friction force, friction, yes or no, frictional force. Okay, then solve it from here. It's easy to solve. Let's say this is your mg. Okay, here is angle theta. So how it will move? One part will go like this and one part will go like this, and this is your normal. So this will become your mg sine theta, yes or no, or this will become mg cos theta. Clear? So we know what is the force of friction is negative mu times n, which is equals to negative mu k because kinetic friction, and n is become mg cosine theta. Yes or no? So can I say work done 1? What is the work done 1? Minus mu k. Okay, wait. So the work done 1 should be, what should be the formula? F1 d1. So minus mu k mg cosine theta bracket d1. Clear? Understand? Okay. Now solve the second part. If the body is going straight, let's say this is straight, so this is your normal and this is your mg. Clear? So can I solve? This is force 1, force 2. Force 2 is equals to negative mu n. Okay, so negative mu, what is n? mg. So what is work done 2? Work done 2 is equals to negative mu mg distance d2. Do you understand till here? Sure. Okay, now just solve them. Okay, I need to add a page here. Give me a second so that I can add a page. Okay guys, now what we have, you need to focus. We have total work done, total energy or total work done, which is equals to your, okay, total work done should be equals to work done 1 plus work done 2. Place all the values. What is the total work done we have? Negative mg d1 sine of theta is equals to negative mu k mg cos theta d1 negative mu k mg d2. Okay, what we are looking for from this equation? We are looking for d2. Okay, so take this value this side. So what we get, if you rearrange them, negative, 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 okay, remove all the negatives, so it will become mg d1 sine of theta plus mu k mg cos of theta d1 is equals to mu k mg d2. Okay, mg, everything everywhere is same, mg and mg. So what we will get d1 sine of theta plus mu k cos of theta d1 is equals to mu k d2. Okay, take out the d1 common from here, d1 bracket sine theta plus mu k cos of theta equals to mu k d2. Okay, so d2, what is the value of d2? Divided by mu k, d1 sine of theta plus mu k cos of theta divided by mu k. Place the values guys, fast. And once you place the value, because we have the value of theta, we have the value of d1, d2, so you will get d2 is equals to 122.91 meter. Clear? Understand the real topic? Sure. Okay, so we have d1 which is 25, cos of 35 degree you need, sine 35, and mu you should know 0.1. Just place these values. Clear? Okay, now time to move to the next question. Okay, yes, this is something very good. How much mechanical energy is lost means friction means F is equals to mu n. Yes or no? You know now this thing. Okay, just you need to apply this thing and nothing else. So, or we have work done, because it is asking about the energy, so that should be work done is F dot D. or which is directly equals to mgh. You can solve like this also. Okay, so mass is given. Mass is 55 kg. Okay, slides down a ski slope at a constant speed. Velocity is given 14.4 meter per second. The slope means the length. Okay, the length is 123.5 meter, makes an angle theta is equals to 14.7 degree with respect to horizontal. Guys, this one is very, very, very easy. I told you need to find the value here. Let's say this is the point A. So at point A, let me make it big. At point A, so what is the value you have? So work done is equals to negative mgh, yes or no? Because kinetic energy is 0, because velocity at the top is 0. So now you can easily solve them. And I told you in the previous question how to solve h. Let's say you have this triangle with you. Okay, there is angle theta, this is your height h, this is L. So h will become L sine of theta. So we can solve work done is equals to negative mg, h is L sine of theta. Place the values. M is 55, multiply 9.81, multiply L is length is 123.5, 123.5 sine of, what is the angle 14.7 degree. Yes or no? Do you understand? This is your work done. This is your work done. So place all the values and solve it. So work done is equals to negative 16.9 multiply 10 raised to power 3 joule. Clear? This is your opposite, means opposing one. He is asking about the loss. Clear? Okay, now the fourth one. This is something interesting. Okay, let's see. A truck of mass. Okay, mass is given 10,212 kg. Okay, moving at a speed. Okay, what is the speed here? mph. Velocity is 61.2 mile per hour. Okay, I'll give you a shortcut. Mile per hour to meter per second, multiply with 0.45. Okay, multiply with 0.45. So what you need to do, 61.2 multiply by 0.45, which will give you, solve it, 27.35 meter per second. Clear? And this is the major point. While doing the numericals, focus. Okay, there is a truck moving with the speed, has lost its brake. Okay, fortunately the driver finds a runway lane, a gravel covered incline that uses friction. Remember this thing. Okay, we are going to use this to stop a truck in such a situation. See the figure. Okay, a truck is keep on moving like this, and now it is going upside so that the speed will reduce. Okay, so this is your part 1, and this is your part 2. Okay, see that in this case the incline make an angle theta is 40.15 degree with the horizontal, and the gravel has a coefficient of friction. See, I told you friction 0.634. So means it's keep on reducing the speed with the tires of the truck. How far means we are looking for this distance x. Does the truck travel before it stops? Let's say your truck will stop here. Stop. It means this is your height. Yes or no? Clear? This is your height x, and here is the angle theta. Final velocity is 0. Okay, so we need to find the x. Okay, guys, I told you something. You need to find out in a very easy way. First thing, total energy at the top point, at this point. Let's say this name is A. Total energy at the top. What is the value? mgh. Yes or no? Now you will ask me, teacher, in the previous question it is negative, now why it is positive? Now just think, in the previous case I use negative mgh, here I am using plus mgh. Now just think, in this case it is going down in the previous case, and here the body is going up, so it should be gravity is positive. Clear? So the total energy at A is mgh. And what is h? Tell me, I solved it number of times. mg delta x sine of theta. Yes or no? Clear? Okay, this is the first case. Now what is the energy? Now we have the two energies. What you need to understand, there are the two energies. One, okay, I will explain here. This, let's say this is your case 1. Now you need to understand two cases. Now when the body is here, case 2, when the body is traveling here, so what is the total energy at point 2? Can I say kinetic energy plus potential energy? Yes or no? Okay, so kinetic energy is half mv square, half mv initial square, plus what is the potential energy? 0. Why? Height is 0. Clear? Okay, now what is going on? Case 3, when it start going up like this, there is a opposing force because of friction. Opposing force. Yes or no? Because of friction. Okay, now solve that. Let's say the body is here. Now first thing, it should be mg like this. So your n normal is like this. Okay, solve it. This part is your mg cos of theta, and this one is your mg sine of theta. Yes or no? And here you have the angle theta. Clear? So the first step, force of friction, F is equals to minus mu k, mu n. Mu n, yes or no? Minus mu, what is n? mg cos of theta. Yes. What should be the work done? Work done 2. Here you can say work done 1. Work done 2 should be equals to, what should be the value? Tell me fast. So it should be F2, and what is the distance? Delta x. Yes or no? So it will become negative mu mg cos of theta delta x. Clear? So now solve it. Total value. Now we need to solve the total value. So we have the upper value, we have the other two values. Okay, now solve it one by one. So we have the total value here. So put them equal. Total value is equals to sum of the other two. So the first one is mg delta x sine of theta should be equals to work done 1 plus work done 2. It should be half mvi square plus, no, minus, here is minus mu mg cos of theta delta x. So what we are looking for? We are looking for delta x. Okay, first of all, m. Remove this. Okay, so now we are looking for delta x. Okay, so delta x is here, delta x is here. So bring them one side. G delta x sine of theta, bring it this side, plus mu g cos of theta delta x equals half vi square. Yes or no? Okay, I will add a page here so that I can explain in a good way. Okay, now solve it. Take x common, this one, take it out. So delta x bracket. What will left here? G sine theta plus mu g cos of theta equals half vi square. Clear? Take this value down. So delta x equals 1 over 2, make it a big line, vi square divided by g sine theta plus mu g cos of theta. Guys, now it's your turn to solve it. Okay, now I'm placing the values. Delta x equals 1 over 2. What is vi? Here the value is 27.35 square. 27.35 square divided by, what is g? 9.81. 9.81. You have the angle, yes or no? Sine 40.15 degree plus, what is the value of mu? Mu is 0.634. After that, g is 9.81 cos of 40.15 degree. So guys, solve this. So you will get delta x is equals to 33.8 meter. Clear? Sure. So guys, I just need to check. Yes. So for question number 18, I covered all the 4 questions, and I thought now you will understand also that how to compare total energy. Yes, you just need to focus that, okay, first I need to check the total energy at the top, and then I need to check the work done 1, work done 2, and compare them and finish it. Just focus on this part. I will show you this statement. Yes, statement number 2, E total is equals to mechanical plus other. If you have the mechanical, sometimes we have the kinetic, sometimes we have the potential, plus the other part. Other part is because of the friction. Clear, guys? So I thought you are clear with this question, and once the question will come in your exam, you are easily solve this. Okay guys, so I will meet you in the next video. Till then, take care. Bye.